We're going to start our videos here by talking about continuity at a point. Now, I'm not really big on memorizing definitions or theorems or anything like that, but this is one I will tell you I will ask about, and it is one that you need to know. So make sure that you know this for your quiz and for your exam. So this says a function f is continuous at a point x equals c. So we're talking about one particular point at x equals c. If the following three things are true. So first, we need the limit as x approaches c of our function f of x to exist. So we need the limit to exist at this x value. F of c needs to exist. Remember, f of c is just the y value of the function. So really what I'm saying is the function needs to exist at x equals c. And then for our third criteria here, those two things from parts 1 and 2 need to be equal. So the limit as x approaches c of f of x is equal to f of c. All three of these things need to be true in order for our functions to be continuous at a point. If any of these fail, then we say that f is discontinuous at that x value, or we might say it has a discontinuity at that x value. So as soon as we find one of them that is not true, that doesn't work, then we can stop and say our function is discontinuous there. So we're going to take a look at the graph of a function. It says discuss the continuity of the function at, and then we've got a few different x values here. So what I like to do for these types of problems is almost to treat these three criteria as sort of like a checklist, and we can use that as a checklist to determine whether or not our function is continuous there. So I like to be able to say whether or not our function is continuous, and then if it is not, give a reason why. So let's take a look at each of these x values. So part A, we want to look at x equals -3. So I'm just going to work through these one by one, and I'm going to see if all three of those criteria are true. So first is the limit as x approaches -3 of f of x. Does that exist? Do we know what that is? So let's look at our function at x equals -3. Here's our function at x equals -3. And it looks like the left and the right-hand side of our function both approach y equals 0. So that means that our limit is 0. So okay, that's good. 2, we need the function to exist at x equals -3. So if I look at my function right here at x equals -3, does it exist? In this case, no, it does not. My function has a hole at x equals -3. So I would say, okay, at f of -3, our function does not exist. So as soon as we notice that this function does not exist there, number 2 is not true, then we say that f is discontinuous at x equals -3. So as soon as we find that one single part that fails, then we can say that our function is discontinuous. Let's take a look at part B here. Part B, we're looking at x equals -1. So for, again, each of these, we're just going to work our way through the checklist. Limit as x approaches -1 of f of x. So if I look at -1, here's -1. The left-hand side looks like approaches y equals -1. The right-hand side approaches y equals -1. So that means that our limit must be -1. So good, our limit does exist. 2, what is f of -1? Does it exist? Well, if I look at -1, here we have a hole at -1 comma -1, so our function does not exist at that point. But if I look down here at our closed circle, it looks like we've got a point right there at -1 comma -3. So that means the y value of my function is -3. So my limit is -1. My function has a value of -3. So for my third one, I need to check if those two things are equal. Well, -1 is not equal to -3. So because those two things are not true, we would say, again, f is discontinuous. Discontinuous at x equals -1. Let's take a look at our next x value. Next we said x equals 2, so we're looking at this x value right here. So let's go ahead and say for part C, x equals 2. Let's look at the limit first of all. So if I approach 2 from the left-hand side, it looks like we're approaching, it looks like this point, let's see, it looks like this point right here, we're approaching that point. So as we approach from the left-hand side, looks like a y value of +3. From the right-hand side, a y value of +3. So that means that the limit as x approaches 2 of f of x is +3. So that's good. That's good to know. The second point we need to check, what is the y value of our function there? So the y value of our function, here in this case, there's no holes, there's no open or closed circle, there's nothing to tell me that the function does not exist right here at this point in my graph. And that has a y value of 3. So that means that when it comes to part 2, it means that f of 2 for my function is equal to 3. Part 3, okay, well this works out nicely. 3 is equal to 3. So we have all three parts of this are true. We've got the limit exists, the function exists, and those two parts are equal. So that means that f is continuous at x equals 3. And I'll point out x equals 3 in particular for this. If you were to look at the graph of this function, I don't think there's really anything that would jump out at you, jump off the page at x equal, or excuse me, that at x equals 2. Oops, then I messed up down here. One thing I got to correct. I said at x equals 3. That was not true. Where our x value was 2. That's my mistake here. So at x equals 2, our function exists. Now, if we were to look at our function here at x equals 2, again, looking at this, there's nothing that really jumps off the page at you here. There's no holes or asymptotes or jumps or anything weird like that. And that's what we like to see for continuity, is honestly kind of a boring part of our graph. There's nothing super big or interesting happening there. That probably means it's going to be continuous, which means we get to do our cool calculus stuff in the next section. Let's take a look at one last example here. We're going to look at x equals 4 this time. So now we're looking at this particular x value. So for part C, again, we're going to start with, okay, what is the limit as x approaches +4 of f of x? Well, in this case, if I look at x equals 4, the left-hand side of my graph looks like it's approaching a y value of, looks like about +4 right there. The right-hand side of my graph is approaching a y value of 1. The left and the right-hand limits do not agree, so that means that my limit does not exist. So the very first one, the very first part of the definition of continuity fails. So that means that f is discontinuous at x equals 4. So these are questions that I like to ask along with limit questions like we saw in section 2.1. I like to give you this graph right here. I'll ask you, okay, maybe what's the left-hand limit? What's the right-hand limit? What's the two-sided limit? What's the value of the function? And then for the last part, I'll say, hey, is this function continuous or not? And for most of those questions, if I ask you those first 4 parts, you'll actually have these two pieces of information already. You'll have that whether or not the limit exists. You'll have the value of the function. So really, it's just going to be this third part that we need to check. But again, please make sure that you know this definition. It is one that I'm going to ask about. It is one that I expect you to know for the exam.